Welcome to our presentation. Uh, this is the group project presentation for computer integrated manufacturing, Lamar University Fall 20 Spring 25 course, and we have the project title is two-cylinder engine assembly and CNC operation. And this is our group member. We have done two-cylinder engine assembly and CNC operation. So we have total 8 people in our group, and I'm presenting in behalf of our group. And my name is MD Shahidul Islam Shakir. Uh, this is our project objective. The project objective is very simple. So we have 11 key parts for engine components. We have first designed it in Fusion 360 and then assembled it. Then we have done the piston. We have chosen the piston for CNC manufacturing. Like we have done the two operations. We'll show it in our slides, and there are some design for manufacturing. Why we choose the uh, piston, and then design for assembly also. And then there are some accuracy and results are also showing. And this is our project flowchart. How the project is going on for all of these design project. And the team management, it is something like we have different people, 8 members in our group, and we have team collaborations to complete this project, and successfully we have done it. And we have project manager, lead designer, CNC planner, and how the documentation will be laid and the presentation will be done. And the collaboration method is done by, like, I'm showing it in this flowchart. It is something like we have weekly meetings and task or distribution with different peoples, and we have tracking, like what the progress about and how we will deliver it to the final reports and the presentation. So modeling quality and complexity. So we have the 11 components. We have designed it Fusion 360. So we have engine block, piston pin, connecting rod, push rod, crankshaft, rocker arm, crankshaft sprocket, camshaft with sprocket, arbor, and piston bulb. And we have used different modeling tools. And first we have designed it on Fusion 360, Autodesk Fusion, and all of the complex modeling tools, extrude, revolve, pattern, fillet, sweep, mirror has been used. And when we are assembling all of the parts, we have used the how rigidity, like revolve, and different kinds of joining operations in the assembly tool also. And this is our 11 parts what we have designed in our Fusion 360 CAD model. So here we have from 1 to 11 we have engine block, piston pin, connecting rod, push rod, crankshaft, rocker arm, 8 crankshaft sprocket, camshaft with sprocket. This is arbor, and this is the piston bulb. And this is our engine assembly. We have successfully assembled it in the Fusion 360, and this is the I've taken the screenshot from our team hub on the Fusion 360, and different people has been done different projects and visual. This is the visual documentation of full assembly. I'm going to the Fusion 360 file, then showing for this like what we have done. So this is our assemble of that part, and we have a hub. So different people done different kind of part here. So something like I'm going for this piston CNC. It has been done by one of our member, and besides this is done another of our member, and all of the things are being created here. So we have just started from the scratch for this project. And something like I am presenting. So this for crankshaft, so it has been designed first by me, then there are some modification by our team member. So everything is in here in our hub, and this is the all of the parts we have assembled. So this is our, like I'm showing here, like different kind of, like these are final assembled engine. So it looks like this. Now I'm going back to the presentation. So we have also done the CNC manufacturing. So we have done two operations, one CNC turning and CNC milling. For in the CNC turning, it is done on this machine Brothers PDO M200 XDI, and for CNC milling, we have used Huss UMC 750. So we have done in the turning, we have done facing, roughing, and finishing, and these tools CNMT and OD grooving tool has been used in the CNC turning. And for CNC milling, we have done the 2D facing, 2D scallop, pencil pass, and the tools we have been used for this machine is like for operating these two 3 milling operation, face in mill and ball in mills, and they have different diameters. So design for manufacturing analysis, like why we done this CNC manufacturing. So it is something like when we are manufacturing anything, we have to reduce the cost and sustainability also. And for this, for the engine, the piston, when it engine will operate, it will have to withstand high amount of heat, and we have to select the material very specifically, and the design is very accurate. So that's why we have done some modification. So we have the single radius simplified, and it will have some filleted internal corners that will avoid tool breakage when it will manufacture, so it will give the easy of the manufacturability. And we have used standard different kind of pin dimensions and tool sizes, and we have the results analysis. So it has shown that we have used fewer machining steps, reduced setup time, and lower cost, which is actually the main for all of the manufacturing things. Like first we have to done the CAD modeling, but if the manufacture cost is high, then it will not be feasible for any kind of fabrication. So then the design for assembly parts, we have the design for assembly analysis. So we have done showing some piston connecting block, how it was assembled. So we have created modular sub assembly for these three: piston, pin, and rod. So this is a piston connecting rod, and there is a pin here. So there are some if I go to the next slide, then I have some, I will show there are some points here in the piston for the pin. So we use the standardized fits, no press tools required, and we have it has enhanced the ergonomics handling, and that means people when they are manufacturing it, it will be much more easy, and it will be assembled, has been improved some efficiency and reduced the operation cost also. And what I'm showing, so this is the pin pocket, like pin will go this way, so this here, so piston pin. So and now the what the redesign of this piston, it is like it has some uniform internal cavity, less deep, and camfer pin holes, precise tolerance, and it has improved the efficiency by 25%. And this is the piston movement. Like my plan was our plan was we have to do the animation, but we didn't do it. It will be our future work, I will show it. So it is something like the piston, it has two cylinders, so one will go up and one will go down. So the results and discussion, so we have completed 11 part assembly here. And so first we have designed 11 parts, then the assemble, and we have shown some manufacture CNC operations, and also design for assembly, like how what we will assemble this thing, what kind of improvement we can do. And the conclusion is that this is our integrated like project for CAD CAM, and design for manufacturability, and design for assembly analysis done. And we have successfully do it by optimizing different kind of variables and parameters. The future plan is like in this project we didn't have the exploded view, like how different 11 components will assemble together. So we have planned for this, and also animation kind of like how their sequence come and go, so it will be much more easier for anyone to see, and how it is has been designed, and all the parts how it was assembled. Then we have another plan for manufacturing like CNC for crankshaft and camshaft, and conduct some finite element analysis for trace evaluation for different points of the different parts of the engine. and explore the additive manufacturing ability. Like additive manufacturing has different kind of prototype. So we have a plan for manufacture a prototype of this engine what has done in additive manufacturing. Thank you for uh, thank you for this watching this presentation.